Or this to the cloud. Okay, so yes, lab this week, lab 6, DM your username. And then you have lab 7 due next week, which is the cow lab. This cow lab is actually going to be the basis for, I think, I'll just go look at it right now. So lab 7, lab 8, is lab 9? No. But yeah, so this cow lab is going to be the basis for your lab this week and your lab next week. So this isn't, I wouldn't, if you're like, oh, I need to take a break week, I'm not going to do a lab this week. Don't make that this week, because this week's lab is a building block for next week. So you want to get this week's done. You want to get it right. You're going to get done early. That'd be so great. So you're going to need it for next week. Okay, so yeah, lab 7 this week. And you also have your quiz tonight, which I'm fairly certain is on classes as well. She'll say it in like homepage or something. Oh, I hate masks. Conceptually, I'll still wear one over. So yeah, quiz 7 is on. Oh gosh, that's going to be annoying real fast. There we go. I'll open that when I get home. Okay, so that looks like that's tonight and tomorrow. So take that. It might be a good idea to try to start implementing this lab before you take the quiz, because they are both classes. So getting a real world hands-on experience implementing one would help you with that, but don't have to. And then your project, the project has been assigned. The project is another big classes thing. The project 3. So I told you last week, like, you don't need to start it yet. So it's due March 26th. Oh, so that's due next week. So now you definitely need to get on the ball just starting it. But it is another classes type project. Its classes are a very fundamental part of this one. So we'll probably take some time to go over this as well. There's a lot more stuff here, but honestly, if you can get lab 7 done, then you can probably start building this with like the basics. Like if you understand lab 7, then you can start building at least the Picuri class. Maybe the Pokedex class is a little bit more complicated, but definitely the Picuri one. But we'll talk about that. Okay, so yes, quiz tonight, lab 6 tonight, DM your username, for your GitHub username, lab 7 next week. And then you also have project 3 due next week, Friday. So it'd be a good idea once you get lab 7 done to finish up project 3, at least not finish up, to start project 3. We'll go over like what's similar between lab 7 and project 3. So classes. Oh, here. What is a class? So in object-oriented programming, which conceptually is just programming with the idea that certain things can be emulated in a computer represented as objects. So you could think like people as an object. What attributes do people have? Class attributes, it says it right there. People have names, they have ages, people have hair colors, people have skin colors, people might be wearing clothes. You never know on that front. But so just anything that might be an attribute of a person, you could have as these defined as class attributes. Those can be stored. Objects can do anything that might be like an action that is associated with them or information you want to get from them. You would create maybe class methods. So you might have a method for people that's like print name or something like that. And so you would call print name on the class object and it would output their name. You could have maybe you had a student object. You could have a get grade function that if you had assignments as attributes, then it would average all their assignments together to get their grade. People might have a location, so you could have a move function that changes the attribute that's their location. But that kind of thing, does that make sense? Where you have attributes, which is just like variables associated with a person, and then methods, which are actions that you can do on a person or using a person or using an object, on an object or using an object. So conceptually, that needs to make sense. Moving forward, if you're told to like make an object, we should be able to tell you like what class attributes or variables someone would have, and what functions, and we'll talk through like how you'd make that. So we'll do it with lab 7 in a second, but this should be true universally. So first, understanding conceptually how you break up an object into the attributes and methods, and then we'll get to the implementation in a second. So the whole point of making objects is that multiple objects can be created from one class. So technically, like in lab 7, we're going to be having multiple cow objects. That sounds weird. I don't know who initially made this, but we're going to have multiple cow objects. And theoretically, you could, instead of making objects, just make variables associated with each, like hard code variables. So like I think a cow has an image and a name. So technically you could just make an image and a name for how many, if you, instead of making a class, like let's say you wanted 3 cow objects, you could just make image 1, name 1, image 2, name 2, image 3, name 3. But using objects, that kind of shortens that. It makes it more modular, more generalized, just more functional for expand. Like if you want to do it more, like if you wanted 1,000 cow objects, you wouldn't want to do name, image 1, 2, 3, 4, all the way to 1,000. Instead, you could just make the cow class and then use for loops to like make multiple cow objects and store them in an array or something like that. So that'd be a lot easier than having your own individual things for that. You could also do it with an array. So like you could have a name array or an image array. So that'd just be 2 arrays. And then the length of the array would be the number of cow objects. But again, it's making it more condensed. The fact that you could represent them as objects means that you probably should. And making that makes a lot of things easier. Like when we get into oh, it's not open. Oh, right here. So in the projects, they're called Procuri objects, basically Pokemon. Each Pokemon object has a species, an attack value, defense value, and a speed value. So if you're doing this without objects, you would have to have an array for each of those things. And now that gets way more complicated. Instead, it's better to have objects so that each of those variables are actually associated with each other instead of using like the index of an array. But yeah, just showing like once you start getting a lot more attributes, that becomes more, it becomes a lot better to have objects instead of just like arrays of values. Now I say that, and even going into programming 2, I have some students who continue to like not use classes. They get around it with just arrays. I promise you that's just going to hurt you in the future. If you try to resist classes, it's going to make your life suck eventually. It might not make it, like it might make sense to you not to do it now in programming 1. Like I've said, I've seen a handful of people get away with it in programming 2. I don't TA data structures, but I'm guessing it's sucking data structures. And I can promise you in my future classes beyond data structures, the like more advanced programming classes, it really, like you just can't. Now there are some that teach different programming paradigms. There's functional programming, which does not have objects, but that'll be even more specific. And they assume you understand objects and they build off of, if you know object-oriented programming, here's the difference with functional programming. So that's still super important. Okay, you can't see shit. Why didn't you tell me? You're not in the Zoom. You can't see anything. You've been following along with what I've been saying? Oh my God. I'm sorry. That's honestly, you're not wrong. I have just been talking. I slightly referenced one side. It'll be up in a second. Okay. So yes, this is just emphasize as hard as I can that please accept classes into your life. Please take the time to really learn this. This is not the week to like peace out for a day for the week. So you need a break. If you need a break, obviously take it. It's always up to your discretion. But I would recommend it not this week. So you get 0% for anything you don't turn in, but you can you gotta manage your time to take a break if you need it. So the concept, here we go. There you go. So last little bit on here is that the concept of a class does not take up any space in memory. So you write this code, like let's say you write this big code for this huge class that has all these functions, all these methods and all these attributes. If you never actually make an object of that class, it doesn't take up any memory. So conceptually, writing this stuff, it doesn't take up any memory. Obviously, there is like the file that might take up a couple bytes, however many characters are in the file, but we don't consider that when we talk about actual memory space like that. Like if there's no object of that type, it's not taking up memory. Like integers don't get allocated, strings don't get allocated, nothing gets allocated if you don't create an object of that class. So that's just conceptually what a class is. So classes are how we implement objects. So some programming languages, they call it other stuff, like struct is another word you might see, but just generally objects are in Java specifically, it's entities derived from the class. So it's actually constructing an object uses that class. So we've seen, I talked about before with like the new keyword, with like scanners and stuff. Scanner is an object. There is a scanner class. So that was already built somewhere else. You didn't have to build it, but you're using the scanner class. So just like that, you will be building your own classes. So here, let me just, I'm gonna create a class real quick. And oh, and in Java, everything's in our class. So we have like the public class hello with public static void main and all that. Don't think too hard about that. Like your main class does not represent an object. Technically you could if you felt like it, but that's just Java. They put everything in a class. That's just how the programming language is built. So I'm gonna make a person class. And then here we're gonna give it a name. And can I zoom in on this? I know I can. Okay, never mind. I guess I can't. Whatever. All right, well, this is good enough. String name, int age. And there you go. This is now a person object. I didn't write any methods, but this is still a person object, plain and simple. If I tried to make one, I couldn't really do anything with it. So these two things are in the same folder. So I can make a person object in here. Do person variable name equals new person. And if someone would like me to zoom in, just let me know and I'll actually put in effort to figure out how to zoom in. But if no one's complaining, I won't spend the time to fix a problem that doesn't exist. Okay, so right there, I made a new person object. Now I can't do anything with this, but I have now made a person object and I have a person class right here. So there, like I said, there's two separate things. If I didn't make this person object, I would still have a person class, but no memory would be allocated because there's no person object. Now I couldn't, now I've made one person object. I can make another just as easily. And a third, oh. And a third and a fourth. Different variables, there you go. So there, I got 4 person objects. You can also make a person array. Looks like that, right? I think I can make an array. Yeah, something like that. Yeah, so this is an array length 6. Each element is a person object. Exactly. Ernesto asked, this is an array with 6 persons in it. Yes. So Yeah, that's just using an object. It's just like any other variable. I could have replaced, well, I guess not with the new, scanner. Yeah, you could have replaced person with scanner. The scanner does take, it has to take in this parameter here, and we'll get into parameters in a second. But, and it's scanner, there we go. There we go. So you could replace person with any other object class or whatever, and it'd be the same formatting. But this is generally how you construct a basic object. We're I'm gonna go back to person. Kind of using this, let's create a function, a method. I'm gonna do void print name, and here's system.out.println name. So right here, what I just did in this function, which is a function inside the person class, I am outputting this variable name. It wasn't initialized in this function, but it's in the class right here. So that means it's going to print out the name associated with the person object that I call it on. So we'll show how to call it a function, a method on an object, but this is going to print out the name associated with this object. So if I go, and this actually is not going to work because there's something that I'm doing just to show you, but if I go into here, let's just do var1. If I do var1, the correct way, what you're supposed to be able to do is var1.print name. Oh, it worked. What? That should not have worked. Okay. Yeah, I know. There we go. Okay, so okay, so you don't need the private there. I guess it defaults to public. Sure. Okay, in C++, it defaults to private. That's my fault. But so right here, you see void println system.out.println name. So if I run it, this is going to print out the name of the object in here. I'm going to put a little out.println before after. There we go. Because the one thing that this has an issue with right now is that we initialized this object, but we haven't given it a name. Oh, look, it's null right there. So name, a string, the default value of a string when it's not constructed at all, has a null value. So there's two ways you can fix it. One way is in here, if I had put just like equals blank or something. So now whenever you construct an object, it'll give it a default value of that. But that's not really the recommended way. The recommended way is by creating what's called a constructor. So in here, we're going to do person and brackets just like this. So this is a constructor. It is the name of the class, then some brackets. And in here, you put name equals something. Well, you can put whatever you want. We'll put default. Sure. So it's a default constructor. This gets called whenever you construct a person object, and it constructs the person object. It does whatever you do in here. So it just gets called when you create a new person object. And whatever you do in here happens. So when I'm doing name equals default, I'll do like age equals 0, sure. So now it's the name and age associated with the person object that this is constructing, and it's setting those to those values. So if we run this code now, look, it printed default because we said set the name to default when you construct an object. And I didn't have to do that. I could comment this out. Like you could actually have this be completely empty if you wanted to and still run it. Because this code just runs when you construct an object. You could put like an output statement here if you wanted to, but it happens. I'm going to keep this. So that's constructing an object. Now, right here, you'll notice that we have these brackets here. like in a function, you can have parameters passed into a constructor. So we can do something like string n and int a, something like that. So with this, now it passes those things in just like parameters. So in here, we do n, and here we do a. So the things, we assign these to the parameters passed in. So if we go to this related problem here now, this isn't legal anymore. So one key thing to note is that once you define any constructor, you have to define all of them. And what that means is that before, when we had nothing here, when there was no, so that this is called a constructor when it's the, this is called a constructor when it's the class name with the parameters. That's what's called when an object gets constructed. When we had nothing here, if you don't put anything, then a default constructor is made for you, and it just assigns all their values to whatever is written here. Nothing happens. No code gets run when that object's constructed. If you write any constructor, though, you're responsible for all of them. So now you no longer have access to that default thing. Even though you only created a constructor with parameters, you don't have the default one anymore. So that's just a key thing to note, because that's going to be important for this lab, because you're not creating a default constructor. But anyways, now you call this like you would a function where you pass in parameters. So we're going to give a name Steven and an age 22. I did not put this in quotes. Like that. So in there, so now there's no errors or anything. When we print out name, it's going to print out Steven. Does everyone kind of get the concept of a constructor? These really don't change much. They don't have a return type. They can or cannot have parameters. You can have multiple constructors. So you could have one that just, if you can't have two that have the same, so you can't have two the exact same parameters. I guess this is technically different parameters because of the variable name, but the exact same order and data type of parameter. So you could have it like this way. Because the order of parameters is important to know which one gets called depending on the order of the parameters here. So if you had two that are the exact same order with the same data type, then it wouldn't know which one to call. But you can have multiple, any amount you want. You can have any, you can have a default and a real one, whichever you want. But just the concept of a constructor is pretty standard across programming languages. Okay, so I think I definitely went far ahead because I was talking about this. I was wanting to show an example of that. Cool. Okay. Objects of the same class show the same variables and methods with different values to them. So right here, the string name and int age, if we had, let's say I created person var2 equals new person Evan. I don't know how old you are, but we're going to fake it with a 19. So if we got this and we run it, no, and then I want var2.print name. So now look at that. We got the before and after for Steven, and then the before and after for Evan. Same functions. It's called the same constructor with different parameters, but they're two different objects, and so they each have their own variables here. They're not shared. That's important. Now, key thing to note, key little asterisks on this for any of you that like your detail-oriented. It's important, but like if what I'm about to say is going to confuse you, don't worry too much about it right now. There is a concept called static, which you will need to know. And static it changes it so that it no longer is unique to an object. So now there isn't one name for each object created. There's just one name for that's associated with all objects of the person type. So now this variable is shared across every single object. It's the same for all of them. So now if I run this, So Steven gets called, then Evan gets called. When Evan's called, this constructor's run, so name is equal to n. So it's going to change name to be equal to Evan. And since it's shared across all person classes, when it calls print name for both of these, it's going to print Evan for both of them. So that's just like the specific caveat. When you see the word static, it means that it's the same across all instances of that data type, of that class. Again, if what I just said confused you, don't worry too much about it. We'll talk a little more about it in the lab because you will see it in the lab, but so it'll be used. It's not that it uses the last one or first one called. It would be just like if, well, I guess you could say it uses the last one called, but it'd be just like saying if I had a string variable here and had it called var3, and then I set it equal to Steven. And then I set it just var3 equals Evan. It'd be like if I did that. So yes, Evan, it will use the last one called, not the first one. And it's because of, it'd be like this. It'd be like saying this. So I personally wouldn't think about it as like its own, it is its own unique concept, but don't think about it as like a new type of information. It's variables work the exact same no matter what. It's just that when it's static, it's shared across all of them. So when you do that variable equals something, it changes it. It changes that one thing, but that one thing is the same for everyone. Okay. And you can actually have functions that are static as well. I'll put a little static here. So if you have a static function, that means you no longer have access to the attributes that are unique to an object. So like right here, it says name, non-static field name cannot be referenced in a static context. So if this was static, since now name is the same across all objects, then you can call this function that's the same across all objects. But if it's not, you don't have access to these member variables anymore. So like I said, we'll see that in lab 7. I'm not going to go super into this. If it confused you, don't worry about it. You'll see it used in a little bit. Okay. So yes, you can think of a class as a cookie cutter and an instance as an actual cookie. Great example. So like if you wanted to make multiple cookies of the same shape, you just make a cookie cutter and cut out multiple of the same thing. But if you make a cookie cutter, that doesn't mean you actually have cookies yet. You have to actually initialize, make the dough, press the thing in, make a cookie. So yeah, each time you create a new object, your program will execute that class's constructor. We talked about a couple different constructors. The one without parameters, that has a unique name called the default constructor. We give that a unique name because of the fact that a default constructor gets called in like a lot more contexts. You don't have to have one. Like I said before, if you create any constructor, you're responsible for creating all of them. So if I created this constructor right here, there is no default constructor because I created one, but I didn't create the default one, so there's no default. And that means that I couldn't do something like this. Or I guess I can, and I am just incorrect learning that Java does so much stuff for you. I prefer C++. I can't do person var3 though equals. What constructor does it call for each of those? Oh, that makes sense. Okay, so got it. When you create an array of objects like this, they get initialized to null. That makes sense. Now I wonder if I had. If I did that, it's still null. So that's a good thing to know. If you create an array of of objects, the default value for each element of the array is null. Good thing to know there. A constructor looks like a method, but it does not. It has this. It has to have the same name as the class. So if I tried to do instead of person, but just arson, that's not a thing. It's not legal. So because it doesn't have the same name as the class, it thinks you're trying to write a method, but you didn't put a return type, so it's mad. You also can't do like void person, or I guess you can. Okay, so method name person is the same as class name, so it doesn't like you to do that. Sorry. Looks like you can, just doesn't like you to do it. But if you write a constructor, it has to have the same name as the class, and it's not a good idea to write a method with a return type and all that stuff the same name as the class, so don't do that. But yeah, constructors, no return type. It has the same name as the class. You can have multiple constructors. We talked about that with the default and ones with parameters. You could have, as long as the parameters are of different data types or different ordering of the data types, you can have as many as you want. And so every class has at least one constructor, because if you don't declare it, it has a default constructor that just does nothing, but it still has one. And then if you declare at least one, then you have to write the default one if you want it as well. But as long as there's always going to be one, be it the default constructor that it declares for you, or one you wrote. So here's examples: class person, attributes name, age, city, gender, behavior. You could have birthday, move, print info, I don't know what the hell. I don't know. Okay. So yeah, two different objects, same class. Member variables, constructor, birthday. Okay, so the birthday is incrementing age, sure. Move is changing the city, sure. Print info is printing out the string that has my name is and then the name. And oh, you'll see here that it's doing this dot. I guess I was not writing that. That's fine. So technically when you right in here, when you see purple stuff, well, I guess, yeah, that's when you see purple stuff, that's member attributes, but there is an implicit this dot. So I'm not writing it, but it's technically there. You just don't see it. And the this keyword is how you reference the object that calls the function. So you're saying the object that calls the function, the name variable of it. So that's technically important. And it's you can see it why it's a little more important if I put name here. So yeah, if I did string name here, you can have a parameter called name that gets into the concept of scope we talked about a while ago. This name right here is in class scope. This name right here, I think this is technically function scope. We don't test you on that kind of thing. But it's a different scope, and so they're different. And the way you would be explicit about which one you want to reference is by doing this dot name equals name. That's how you'd be explicit about it. So that's definitely important. The way I avoid writing this keyword is I try to avoid having two variables in the same scope that have the same name, two variables in different scopes that have the same name. My preferred way of dealing with it, but however you want to is up to you. Okay, so cool. So this keyword, awesome. Additional examples, sure. So cars, persons, models. Okay, so that, like, now that I've told you all that, if I said make a class that has XYZ attributes and XYZ functions, and I like explicitly said what the functions did, I should expect you to be able to make one. I know that obviously it's your first time seeing it, so you stumble through it, may have to look up some stuff to help, or come to like questions, but just general idea, you would understand how to make it. So does anyone have like questions about how you would make a class, and I can like walk through like a specific example, like a test case or something like that? Obviously, if you come to me later, it's like, I don't know how to make a class, that's totally fine as well. And we'll work through it. But anything that I skipped over that you're like, that specific part was confusing to me, I will happily go over it again. Okay. So now you generally understand the idea of a class, there's some more terminology involved in classes. So there's two words, getters and setters, accessors and modifiers, that they are written so often that it's, oh, this is talking about public and private. That's okay. I'm ahead of myself. We're not going to do protected yet. Oh, yeah. Okay. No, that's right there. Mutators and yeah, getters and setters. Okay. So inside of a class, you can limit how available information is. So right now, with what we have, I don't think we can do system.out.println var1. Oh, yes, you can. Okay, so right now, this is legal. So instead of actually using functions, methods in these classes, we could instead just like print out whatever information that we wanted to right there. That's great, but sometimes you don't want people to be able to do that, because this also, the way we have it set up, they could do var1.name equals evil, and then var1 dot print var2 dot print. It's like with this right here, running all of this, we'll see it's Stephen and Evan, and then we changed var1 name to evil, so now it's evil and then Evan. So the fact that people can change it like this might be something you don't want people to be able to do. This is more important when we get into like repositories for bigger companies or like a big project where you make something that you want people to just be able to use. And if they did this, they could fuck something up. Like if you assume that a variable shouldn't be able to be set to evil, then being able to do this would be bad. So in here, we say explicitly private. So there's two like more important, there's technically three, because there's protected, and then if you don't put anything, it sets it to whatever you put here. So right here we put public. If we put private, they would be private. But default here is public. And then two more important ones are private and public. We also have protected. We'll get to that more in lab 8. And this makes it so you now no longer can just directly do var1.name. So you can't do that in any context, either to print out the information or to change it. Either one of those no longer allowed. But now what happens if you want people to be able to get the information but not change it, or to change the information but not get it? Well, you still need to keep it private. And so private means they can't directly do var1.name and change it, but you can have what's called getters and setters. So if we do void get name, actually no, this would be a string return type. Return name, and then void set name. This takes in a parameter. There we go. So these are getters and setters. And so using this with private variables, you can limit the access. So you could just have one or the other or neither. If you have both of them, then honestly, you should probably just make it public. But if you want it to be limited to one or the other, you can make it private and then have only one of these. But so these are called getters because you're getting information, and setters. They also sometimes are called accessors and mutators. That's a more like specialized word. But so if you see either one of these four words, you should understand what that means. Methods can also be private or public. So right here, this is a method. You could make it private or public. And now when I'm just talking about getters and setters, the concept of private or public, you might be like, why would you do that? Though it can still kind of work, yeah. So with that, it would be like, I want this function to exist because I want to be able to use it, but I don't want people outside of my class to be able to use it. Oh, so when you do private, you can't use it out here, but you can still use it in here. That's important. Sorry, I don't know if I specified that. But so this string name is private, so we couldn't do var1 dot name, but in here we can still do this dot name. So private makes it so you can only access it while you're inside this class. And so same thing with variables, functions. You're like, I want this function to be accessible because I want to be able to use it, but I don't want people outside of my class to be able to use it. That's why you'd have that concept. Exactly. So it's like encapsulation. Exactly. Close enough. So yeah, public and private, limiting access. Public means available to just wherever you have an object of that type. Private means limited to only inside the class. And then if we'll go over protected more next week, but protected, just so you kind of hear about it at one point, protected means you can access it inside the class and inside any class that inherits that class. So it's that inheritance concept, the subclass access, but it's not public. So just where you can't use it anywhere you have access to an object of that class. Okay, so live coding, I guess, sure, we already did some live coding. Actually, I'll avoid this. We already did some live coding. So private fields, team name, team wins, team losses, that would be like, if we told you to make private variables that were those. And I'm doing live coding now because I enjoy doing that with students. Okay. So in here, obviously it's not a team class, but if you wanted to change this class name, you can't just change it to team because the class name has to be the same as the Java file name. So you'd have to go to here instead of just changing it to team there. Go to here and do refactor, rename, team, refactor. So that's important. So it says declare private fields, team name, team wins, team losses. You would just do private, team name, private string. And then same with private ints for wins, losses. Mutators, set team name, set team wins, set team losses. So we talked about that with the person. And so with mutators and accessors, if it doesn't say if it should be private or public, just think about what those are. So mutators and accessors should be public. And then get win percentage, it doesn't say to make that private or public. So just if it doesn't say anything, just don't put anything. So it specifically said to make these private, but for those, since it doesn't say anything, just don't put anything. And since the class is public by default, and we put that there at the top, it'll default it to public. Okay, there you go. If you would like to try this out yourself, you should be able to do this. I'm not going to keep going with it because I would like to talk about some more stuff. But this is something that at this point, seeing this, you should be able to do. The weirdest thing is this like private part. But everything else, you should be able to make setters and getters. And remember, right here, even though there's nothing in these brackets, they are setters. And so the setters have something in those brackets. We just didn't put that for you. Getters don't have anything in the brackets. And then those are member variables, so nothing there. Okay, so that's classes in general. Any questions on that? Ernesto asked if IntelliJ can generate getters and setters. Just use Eclipse at this. He said like Eclipse. Just use Eclipse at this point if you want to use Eclipse. can it generate? Yeah. So it can generate getters and setters if you right click and then generate. You can generate a bunch of stuff if you want. But that's more shortcuts. Try not to rely on those because you won't have access to that in like a test or something. So be able to do it without that. But yes. Okay, cool. So lab 7, the CalSay lab. Like I said, this lab really doesn't take too much code, though I guess we haven't talked about the command line interface. So that's, yeah, we're not using the terminal. We're just using IntelliJ. And you can also use Zybooks. That's where I would do it out because you have unlimited submissions. So I'll just run it in Zybooks. You have to create a cow class. It has all these functions and constructors. Notice a constructor, but no default one. Do not put a default one. Think about what attributes the cow has. You can look based off of the getters, what attributes it has as well. So you do have to make this. I would probably make this first. You then have access to this class heifer generator. You'll see it right here. You don't have to do anything to this. The only thing you care about this is that there's this get cows function, and that returns an array of cows. That's all you need to care about. And then finally, this is another class you make. So you make the cow class. You don't make this heifer generator class, but you have to make this class CalSay. This is where main will be. You can optionally create these functions. Just we talked about it in the lab doc a little bit as well. You guys haven't done any command line interface stuff yet, so I have to talk about that, but that's not in here, which is a little sad, but that's fine. I wouldn't worry about testing with the script too much. Cool. Yeah, I'm just gonna hop into doing the command line stuff because that's a little important. Okay, so here. Delete. Shrink. Open in Explorer. Source folder. I want heifer generator. You can technically put cal test if you want to in there, that's fine. But yeah, both of those need to go in there. Or just the heifer generator needs to be in there. The other one doesn't have to be. And then in here, you need a cow class. And you need a CalSay class. And then the cow class, we gave you a fair bit of stuff here. So like, if we just look at this, just take it from here. Public class, cow class. So there's some member variables. I'm not gonna go over that, but then public cow string name. Public string get name. Public string get image. Public void set image. String underscore image. There we go. So with that, like you need all these. There's gonna be some member variables not written here. These two middle ones are angry because they have a return type, but nothing's returned. So I'm just gonna put a little return empty string there. There we go. And so now that's done. this now doesn't have any errors anymore. Yes, okay. So this is all of the important parts of cal without the actual functionality of it. So once you have these things, now any other class that uses cal objects knows that those are going to exist with those parameters and those return types. And that's all it needs to know to not crash, like to compile. So if I didn't have this in here, you'll notice that there's some errors here. If you want to just get rid of the errors, you can just do that. But remember, that's not all you have to do. You do have to actually implement them in order for it to work properly. But that'll remove all the errors here. And then using this, what you need from here to heifer generator, the whole point of this class is just to make the cal array. So you do not need to read this at all if you don't want to. Just understand that this returns an array of cows, and each cow has a name and an image. It's like you can read this if you'd like. It's probably helpful. You should be able to understand this, but you're not doing anything in there. So in here, just at one point, you put cow array equals, and then to call a static function, you do the class name dot get cows. So static function means you don't create a heifer generator object. You just do the heifer generator dot get cows. So that's how to get. Oh, and let's put a main. So that's all you need from heifer generator. Cool. And the next important thing that you guys might not have seen much of or at all is the command line interface stuff. So because we're not all in person in the labs in our building, we don't use the command line for this as much. So you'll notice that there's like throughout this lab, there's a lot of notes that talk about here we go. It's like reminder, students are not enforced to use a text editor plus terminal complete LET7. They can just use IntelliJ, not required to make a CISE account. So all that stuff, like we're really emphasizing that because if you go into here, oh, it's not using what I want. Open with, choose another app, Chrome. There you go. So if you look at this, there's a lot of stuff in here. It's like tools, use these tools, command line interface, testing, like anything that's optional you don't have to do. But you definitely need to make a cow class. You need to make a cow state class. And we're still doing command line interface stuff just without actually requiring the use of command line. So what I mean by that is that in IntelliJ, so let's just run here. Cool. So up here, there's this configuration stuff. We haven't really messed with it. We're going to be messing with it today. So get something that just runs your main. So in here, just put system.out.println main ran. So with that, we save this, run it. Oh, I put an extra bracket in there. That's fine. So in here, this ran the main, and so that means this configuration runs it, and go to edit configuration. So we're going to mess with that one. Someone post in the chat. Kale, you're joining very late. Though I guess I didn't turn on the thing. I don't know exactly when you joined. I didn't turn on the noise, so I don't know exactly when you joined. I'll go see if I have you down for showing up late other days, and then I'll figure out what to do. But no joining late. Stop that. So yes, in this specific configuration, so this one was an old one. I'm honestly just going to delete it. Delete. There we go. But so this configuration right here, the cowstay one, we're running that. In here, program arguments. That's what you can mess with. So in here, from this, you can just take everything after cowstay. So Java cowstay. Everything after that is the different arguments you can have. So there's 3 different ones we'll take. There is just -L, There's dash n followed by cow and then message, and then there's just message. So let's take this right here. Just copy and pasting that to there. So with this, technically when we're actually running it, cal and message will replace, like down here we give some examples. So here, cal say no dash L or dash N, so you just print out hello world with the default cal. Here, dash N, kitten, hello world, so it's kite. I'm just gonna call it kitten because I hate saying that word. Just my mouth does not like it. So dash N means search for this cow, and then print out the message associate, and then with that little image there. Dash L by itself, you just print out heifer generator. Dash N, and then a word, and then more words. It could not find the ninja thing. And then here, hello dash N kitten. There even kitten, even dash N was not first, so you just the whole thing is a message. So I'm going to talk about how to get the command line argument stuff, but in your head, think about like if you had access to it, you have to check just that first thing to see. But so let's get into like how you'd access it right here. So I'm going to click, we put this in the program argument section. Click apply, okay. And so now those things are going to be stored in this array right here. So main ran in here, I'm going to put for I is equals 0, I is less than args dot length. And then system dot out dot print line args I. So with that, we will see main ran, and then each of those things broken up. And they get broken up by spaces. So if we had this one right here, edit configuration, there, apply, okay. Run that, there you go, hello dash n kitten. So each element of this is the words from that we put into this configuration, broken up by spaces. So each space makes a new element. If we put a bunch more spaces in there, there'd be a bunch more elements. So that's super important. So your job is to take, that input and check to see if it starts with a dash L or a dash N. If it starts with the dash L, then you just list all the available cows. If it starts with the dash N, then you take the second element and you search for your array you get from heifer generator for a cow that has the same name as that, and then you print out a message with that image underneath that this cow represented. And if it doesn't start with dash L or dash N, then you just print out the message by itself with the default cow. And the default cow is whatever cow is in the index 0. I'm saying that whole like searching and index 0 stuff because the heifer generator inside Zybooks is different than the one we're giving you. That is very important. The heifer generator in Zybooks is going to be different than the one we're giving you. And so that means you should not just hard code it. You could still pass some, actually, no, we might have changed that. Before in the past, you would still be able to pass some test cases if you hard coded it, but it is, like if you hard code it, you're not gonna get full points. You have to search through that array to find the cow that has the matching name. And so yeah, you'll be implementing each of these functions. You can use get name to get access to the name, just do like a loop through each element of this. Yeah. Any questions on that implementation? Okay. So the last thing I'm going to discuss right now is the project. Do I have the project here? No. assignments. So yeah, you definitely should be starting on the project. If you took a break last week, that's fine, but definitely start. And what you can start with, like, obviously just read through it. But you're going to be making, technically, I think it's 3 classes. Yeah, so you're creating 3 classes. One of them is the Pakuri class, and that one's kind of like your cow class. So in the cow class, you had a constructor, and then getters, setters, and then there is this evolve function that's kind of new, this evolve method. But we tell you what to do with it. So it's double the attack, quadruple the defense, triple the speed. Excuse me. So after doing this lab, it's definitely more advanced. It's not just like a one-to-one. Like if you did the lab, you like guaranteed can do this. You're gonna have to think a little bit. But you definitely have all the skills you'll need in order to make the Pakuri class. So definitely get started on like that. By the next lab, that should be done. This should 100% be done. Obviously, there could still be some bugs, but you should think that this is correct, and maybe you'll have to debug it later. But it shouldn't be that. It shouldn't be that crazy. The next class you got to make is this Pokedex class. This one, well, actually, I think it has an array. Yeah, so it contains all the Pakuri that you encounter, like you add that the user in the actual main program has in the Pakuri program.java. So Pakuri program.java will have a Pakudex object, and that Pakudex object will have an array of Pakuri. And so in here, that's what you had to keep in mind. So you have a default constructor that initializes the array to 20, capacity that actually initializes it to an actual capacity, get size, get capacity, those just return things. Get species array returns the array, get stats, sort Pakuri, add Pakuri, and evolve species. Those are what actually be like really functional. You have to write some unique code for that. So maybe these first ones you can do on your own, but these 4 right here might be a little harder. Just like searching through the array, sorting the array, adding an element to the array, seeing if the species is in the array and then evolving it. So just calling the .evolve function on it. But yeah, you'll need all those things. And then finally, your actual Pakuri program.java will have this menu and be able to do all the things in the menu. So one unique thing about, well, there's a lot of unique things about this, but one unique thing I want to point out is that the user can call some of these things and they can legitimately fail. It's not that the user gave bad input, it's that it failed is like there is not a like if you wanted to evolve Pakuri and they gave you a bad Pokemon that doesn't exist, there's just no such Pakuri. So you do have to be able to handle bad input in that context. And I think this is one of your first examples of like input. Excuse me, thank you. Input that's valid as part of the menu. Like they did select valid menu options. It's just invalid somewhere later on. So that's important. So like I said before, you definitely should start on this. You have until next Friday, so you definitely don't need to finish it anytime soon. But I'd say by next class, definitely at least have the Pakuri class done, because you'll still have to do this plus your other labs. Okay, any questions on lab, on the project, on classes, anything you want me to show or see? Okay, so with that, we are not done. Before anyone leaves, let me just keep track of who's here or not. Just because I did not turn on the sound to ding, which I like to do just to keep track of when people joined. So I got Daniel, Evan, Mayor. He was here, but he's sick. Stuart, Ernesto, Kale. So I don't have Jed. I saw when you joined, Jed. You were definitely early enough. Yeah, Kale, if you hadn't said anything, you would have been easy because I didn't put that sound thing on. Stuart, John, I don't have you. Yeah, I'm not gonna worry too much about this week, honestly. Daylight savings time happened. Yeah, no, I'm not gonna worry about it. You guys are fine. Okay. So with that, I will say lab is over. This week we do have a new lab assignment. So if anyone would like to pair up for that, just say something in the chat and I'll pair up people. As always, if there's one person, then I'll do something special for that. If there's an odd number, I'll do a group of 3 that's not one person. But if anyone would like a group, just say something in the chat. Ernesto, would you like a group? Okay. Some people love pair programming, so I fully support that. Okay. At this point, you're allowed to. I'm gonna stop sharing and stop recording.